To video lesson. Today's topic, that is mensuration, that is continuation of the previous session. This is combination of solid figures. Previously we have learnt what is the what are the three-dimensional figures and what is the difference between the surface areas and volumes of the three-dimensional figures, and how to remember the formula in mensuration, and I have explained some illustrated examples also in mensuration, and this is continuation of the previous lesson. See the combination of solid figures. See, you have explained what are the solid figures. The solid figures like a cylinder, cube, cuboid, prism, pyramid, hemisphere, sphere, all that. When you combine those objects to form a newly formed objects, to find the surface area of such type of objects, like see here, we regularly see this is a water tanker. So what are the combination of solid figures in this? See, when you closely observe, here this is the cylindrical part. This is a cylindrical part, and we can observe two hemispheres attached to the two other ends of the cylinder. And this is the combination of one cylinder and two hemispheres, and this one is a ice cream cone. So in this ice cream cone, you can observe one conical portion and one hemisphere portion attached together to form a new object. So this is these two are the combination of solid figures. See, we all observe this is a flag you observe in your school premises when you uh, uh, this August 15th and 26th January, we regularly hoist the flag, and this is the flagpole. The quantity of the paint required to wash to paint this flagpole, and to construct the flagpole, the amount of the quantity of steel or iron is required. For all those questions, we have to know about the surface areas of individual solid figures. See what are there in this flagpole. So one cylinder is there, and one cube is there, and two cuboids are there. Two cuboids totally combined together to form a flagpole. So for this, you have to, for the surface area of this flagpole, you have to find out the lateral surface areas of cube and two cuboids, and the cylindrical part also, the curved surface area, you have to find out. See, let us move on to one more example. This is a some oil tanker we observe in our regular life. This also combination of three-dimensional figures. See, in this lorry, we can see one cylinder and two hemispheres attached to other ends. See, this is the so in this, we can see here the one cylinder is there and two hemispheres attached on both ends of the cylinder to form a new object. So what are there in this? One cylinder is there, one hemisphere is there, and one more hemisphere is there. All these three-dimensional figures, when they attach to form this new object, to find out the surface area of this newly formed object, we have to find out individually the curved surface area of hemisphere plus the curved surface area of the cylinder and the curved surface area of the hemisphere. We have to add these three to get the surface area, the total surface area of this solid object. See one more example. This is what are there in this full object? What are there? One cylinder is there. This is a scent bottle, isn't it? In this scent bottle, one cylinder is there, one more cylinder is there, one hemisphere is there. So to find out the surface area of this scent bottle, you have to find out the separately the surface area, the curved surface area of this bottle, the curved surface area of this cylinder, and the curved surface area of this hemisphere. Then sum of these three, you can get the surface, the total surface area of this scent bottle. See here, this is also what are the two three-dimensional solid figures attached together in this figure. So one is the cone is there, and one more hemisphere is there. These two are the flat surfaces. When we join these two flat surfaces to form a newly formed object, to find the total surface area of this object, we have to find separately the curved surface area of this cone and the curved surface area of this hemisphere. When we add these two, you will get the total surface area of the newly formed object. See, we'll work out some problems. The first problem is, so read carefully, the toy is formed of a cone mounted on hemisphere of same diameter. The diameter of the base and height of the cone is 6 centimeters and 4 centimeters. So determine the surface area of the toy. So let us draw the object here. So cone is mounted on the hemisphere. So cone is there, which is mounted on the hemisphere, and it is given the base and height. The first quantity is base. So base of this hemisphere and cone both combined together, you can take the base, that is the radius, that is the diameter. You can say the diameter of this will be 6 centimeters. So naturally the radius will be 3 centimeters, and the height of the cone is 4 centimeters given, and you have to find out the surface area of this newly formed object. So how to find out what are given, what are the dimensions which are given. Here the diameter of the base is given. How much it is? It is 6 centimeters. So the radius of the cone and hemisphere both are, that is equal to 6 by 2, you will get 3 centimeters. The height of the cone is also given. The height is 4 centimeters here. So how we will work out? So here in this diagram, we don't know what is the slant height of the cone. So we have to find out the slant height. As we know the formula to find out the slant height, that is L square is equal to R square plus H square. We'll substitute the values. The R value is 3, the H value is 4. So 3 square is 9 and 4 square is 16. You will get 25. That is equal to, when L value will be the root of 25, that is equal to 5 centimeters. So like this you can find out the slant height of the cone. Now we'll move on to work out what will be the surface area of this newly formed object. So in this we can observe two three-dimensional figures, two solid shapes are there. One is cone, the other one is hemisphere. So you can find out separately, that is the curved surface area of the cone and the curved surface area of the hemisphere. You know the formula will be pi RL for the curved surface area of the cone, and the hemisphere CSA will be, it is 2 pi R square. So here when you observe in these two terms, we can see pi R. So I have taken the pi R as common outside. When pi R went outside, what remains inside? Here the L, and here two R's are there. One R went outside, so one R remains inside. So like this, you can put the pi value I have taken as 3.14, and the R value, that is the radius, is 3 centimeters, and the slant height we know it is 5, and 2 into the radius will be 3. 3 2s are 6. When you add these two, you will get 11, and when you multiply 3.14 into 3, you will get 9.42. When you multiply these two, you will get the surface area of this newly formed object. How much it is? 103.62 centimeters square. So from this you can find out the surface area of this newly formed object. One more example I'll explain. See, one more example I have taken. This time I have taken a storage tank. A storage tank consists of a circular cylinder with two hemispheres stuck on either end, and the external diameter of the cylinder is given. How much it is? It is 1.4 meters, and the length will be 8 meters. So find the cost of painting outside at the outside. See here carefully, outside he is mentioning. So outside at the rate of rupees 20 per meter square. So first we'll draw the diagram how it will be. See here the storage tanker. One cylinder is there and two hemispheres stuck on either side of the cylinders. So the diameter, isn't it? The diameter is given. How much it is? 1.4 meters. So the diameter is 1.4 and the length of the storage tank is also given. How much it is? 8 meters. So you have to find out the paint the cost of paint required to paint this newly formed object to at the rate of for 1 square meter, it costs about 20 meters. So in this figure, you have to find out first what will be the total surface area of this figure. Let us work out. So what are given? The length is given, how much it is? 8 meters. And the diameter is given, how much it is? 1.4 meter. From this you can find out the radius, that is equal to 0.7 meters. So in this problem, which formulas will apply? Which formulas you have to remember? Which formulas you have to remember? So the first one is hemisphere, LSA, hemisphere, LSA you have to know, that will be 2 pi r square. And the cylinder LSA also you should remember, that is 2 pi r h. So we'll work out the problem now. So this is the problem here. The surface area of the storage tank will be, there are two hemispheres, isn't it? Here one hemisphere is there and here one hemisphere is there. So here, so in this we'll work out the what is given in this. So in this, so this is the problem I'm explaining, isn't it? So in this, till now, till here we have reached. So I'm explaining this one. So the surface area of the storage tank is two curved surface areas of hemispheres plus CSA of the cylinder. So the curved surface area of the hemisphere will be hemisphere. You know what will be the formula for that? 2 pi r square, and the CSA for the cylinder is 2 pi r h. So when you multiply 2 into 2, here you'll get 4. And what is common in these two? Both 2 is there, pi is there, and r is also there. So I have taken 2 pi r outside. What remains inside? Here 4 is 2 into 2. 1 2 outside, 1 2 inside. And here 1 r outside and 1 r inside. Here 2 pi r went outside and h remains inside. We'll substitute the values now. The pi value I have substituted, that is 22 by 7 here. And the radius of this is, we got the radius is 0.7 meters. I have substituted here 2 into 0.7 plus the height, that is the length of the cylindrical part is 8 meters. So I have substituted here. So when you multiply these two, you'll get 1.4 and 8. When you add these two, you'll get 9.4. See here, 8 plus 1, 8 plus 1, it is 9, 9.4, 4.4 into, so here, carefully, here 44 I kept, here I have kept 4.4. Why? Because when you multiply 1 with 44, you'll get 44. And point is there after one digit. Point is there after one digit. So you have to put a point after one digit. So here you'll get like this, and when you multiply these two, and you'll get how much it is. This is so this one, when you multiply, you'll get like this. So is that problem finished? No, you have to find out the cost of painting. The cost of painting for these solid objects. For that, you have found out the surface area. That surface area, when you multiply with 20, you'll get the amount required to paint this object. So next problem, one more problem. See here, I'm explained regarding previous two problems are regarding the surface areas, and this problem is regarding the volume of the newly formed object. See here, the cylindrical pencil is there. You all use the pencil, no, for drawing and all. So pencil is there. When you closely observe the pencil, how it look like. So middle portion, you can see one cylinder is there. The bottom look like a hemisphere, and top, when you sharpen the pencil, it look like a cone. So one cone is there, one cylinder is there, one hemisphere is there in this pencil. Isn't it? See, the cylindrical pencil sharpened to produce a perfect cone at one end with the overall loss of its length. So when you sharp the pencil, the some of the wooden portion will be lost. So nicely a cone will be formed. The diameter of the pencil is given, it is 1 centimeter, and the length of the conical portion is also given 2 centimeters. So calculate the volume of the peels. When you sharpen the pencil, the peels will be left over. Now that peels weight you have to find out the volume of the peels. See, this one is the pencil. See here, this one is the pencil. When you sharp this pencil, so some of the peels will be left out. That weight you have to find out. For that weight, the total pencil we need not we need not consider. We'll consider only this portion. So the diameter of the pencil is given. It is 1 centimeter. So here the diameter will be 1 centimeter, and the length of this conical portion is given. It is 2 centimeter. So here, what is we need? We need the volume of the cylinder and the volume of the cone. Volume of the cone. So here the problem. Look at this problem. The diameter of the pencil is 1 centimeter. The radius of the pencil E will be the diameter by 2, that is equal to 0.5 centimeters. The length of the conical portion, that is the height of, it's given, it is 2 centimeters. Volume of the peels. When you sharpen the pencil, the volume of the peels will be, so the volume of the cylinder of length, this portion volume, and the volume of the cone formed by the cylinder. So before forming the cone, what will be the volume of the cylinder for this portion? That volume you have to find out. And presently the cone is formed. That cone volume you have to find out, and you have to subtract this cone volume from the cylinder volume. Then you can find out the volume of the peels left over. See here, I have taken the volume of the cylinder, that is pi r square h, and the volume of the cone will be 1 by 3 pi r square h. Here pi r square h is common, I have taken out. So here 1 minus 1 by 3, you'll get 2 by 3. When 1 by 3 is subtracted from 1, you'll get 2 by 3. So I have substituted here the pi and r square, that is 0.5 into 0.5, that into 1 into 2 by 3. So like this, and the pi value here I have taken the pi into 0.5 into 0.5, that is equal to 5 5s are 25. Here after 2 digits you have to put the point, so 25 before 2 5 I have kept point here after 2 digits. So I have multiplied, and I got like this. And next one, see here the volume of the peels, that so here I have taken the pi value as 3.14 into 0.25 into 2 by 3. When you multiply and when you solve this, you will get the volume of the peels will be 1.05 cc, that is cubic centimeters. So I have given one problem here. Test your knowledge. See here, I have given one problem. This closely look at this object, newly formed object. See here, this is a cube is given, and you have to. This is a wooden article made up by a scooping of cubical form each side solid cubes. So these are hemisphere. When you scoop into it, these are the holes formed on 1, 2, 3, 4, 5, and 6 sides. So the side, the edge of the side is given, how much it is, 10 centimeters. You have to find out the total surface area of this article. So for that you have to find out first the volume of the cube. You have to find out the volume of the cube. Formula will be a cube, and there are 1 2 3 4 5 6 hemispheres will be there. So 6 hemisphere, 6 into hemisphere LSA you have to find out, that is curved surface area of 6 hemispheres. And when you subtract 6 hemispheres from the cube, you can find out the total surface area of this newly formed object. So like this you can find out the problem. So thank you very much. This is all about the surface areas and volumes of combination of solid objects. So this is very important, and you may get for 4 marks question in problem solving when you try to learn, read the problem one to two times and draw the suitable diagram and select the suitable formula to substitute and slowly solve the problems. When you solve multiple problems and you have to create problems by on your own, when you create the problems, then you can easily solve the problems. When you practice the formulae and when you on your own, you can create this small little small problems and try to solve those problems. You will be perfect in that. Thank you everyone for listening.